previously of this lecture, by the way. Welcome to 445L. I'm going to do a Lab 6 demo. Feel free to ask questions along the way. The goal is to go through a first pass of a PCB layout. That's my goal. And so if you look at the steps that you're going to see in this process, I'm going to paste my Lab 3 into the starter file for Lab 6. I am going to connect up the single chip TM4C123 to my hardware, all to my I/O devices, and then after I do that, I'm going to delete the launch pad, which was part of my Lab 3 circuit. I'm going to choose my power strategy. I'm going to add debugging. I'm going to choose a box. And then the fun part will be putting the parts down. The unfun part will be doing the routing. And then it's sort of a simple part. Once it all works, we'll create a piece of paper. Which is a surrogate of the printed circuit board. So I'm going to go ahead and pass the box, one of the boxes, and the board around. Grab it so I can stay audio connected. All right. So the first step, like I said, is to take a copy of your Lab 3. I'm going to butcher it, so make sure it's a copy. And then you're also going to need a copy of Lab 6 Startup. And I'm going to butcher them, so again, I'm going to make them a copy. So I'm going to open up all three in PCB Artist. Now, they just launched a new version, which I haven't upgraded to yet, so if you're in version 3 or 4, it don't matter, it should be fine. Okay, so this is not what it looks like when you start. I'm going to start from scratch, okay. So in PCB Artist, I want to open 3 files, okay. I'm going to open the solution to Lab 3. This is my solution to Lab 3. I'm going to open the solution to the starter file, sorry, not the solution, the starter file for Lab SEH for Lab 6. And open the starter file PCB. Okay. The next step is since I'm going to butcher these and I might want to go back, I'm going to save this as my Lab 6 with my names on here. Okay, so the way that this application works is if the SEH file and the PCB file, which have different extensions, exist with the same name in the same folder, they are connected. So if you look very carefully here, I've just created 2 files with these 2 files here are the same name, but one's the SEH and one's the... Okay, any questions on that? All right, the next step is to go to my Lab 3. Now you can do this by subtraction or do this by addition. One of the simple ways to do this is to first subtract all the stuff that doesn't matter, like the frame. So I click on things I want to throw away and delete, like my name. All of that crap don't mean anything. If you zoom into this, you will see this is the booster pack power, which won't exist anymore, so I'm going to throw it away. Delete. Okay. If you look and see that I didn't use port F on my Lab 3, so I'm going to throw it away. I didn't use port C, so I threw it away. And so I didn't use port B. Now you know why I chose Lab 3, because it was simple. Okay, so I used port E and port B and port A. Okay, so this is my Lab solution. Okay? So I'm going to select. Now you can only copy and paste in PCB Artist if the files are both open in the same instance of the application. So don't open 2 copies of PCB Artist and try to paste one into the other. That don't work. All right, so I'm going to do a copy. So I've copied everything which is my Lab 3, which is the switches, the speaker, and the display. Copy. Okay, and then I'm going over to this other SEH file, the Lab 3 SEH file. I'm going to paste it. The next step is critical. I want you to think about what it's going to ask you. Okay? If I do a paste, it's going to go, oh, I see two grounds. There's this ground and there's that ground. Do you want to connect them up together? Yes. That's what ground means. Connected together. Now, don't hit all yes. Actually, all yes would be fine, but it'll be fun to go through the other ones. Okay? All right, same thing. You notice there are two PE zeros now. There's a PE zero on the booster pack that's connected up to my switch, and a PE zero on the single chip, which I've just pasted in there. I want them the same. Okay? Now, if it says to connect PE0 to PE1, that's probably a mistake. Okay? That's why you want to think about it. PE1 to PE1, that's good. Now, here's another one, 3.3. Now, most people only have a single 3.3 power supply. Now, you could build a system with multiple 3.3s, but when you get to lab 11, you don't want to have half of your thing connected up to this 3.3 that's somehow not connected to that 3.3. So yes, I'm going to merge the two 3.3s. Again, PA2, PA3, PA4, PA5, PA6, PA7, PD7, which I use to run the SD card. All right. Now I have my NPN transistor, so I have a net called Q1 base. You probably won't see this unless you have a Q1 base, but the minus side of the speaker, the plus side. Okay, I didn't. Okay, now before I let go of the mouse, you can you can see that I have a red background of the thing I'm pasting in and a black of what's there. The trick here is to try to get it in the page somewhere. Okay, get it in the page somewhere. And so it's going to be to your strategic advantage. Now I'm not clicking, I'm dragging. And I don't want to completely overlap it because let me put it over here actually. This one. I don't want to completely overlap it so it's hidden, but I want them sort of close. You can see I'm dropping PE4 of the booster pack near PE4 of the single chip. And then I'm going to click it once, and it let go. It didn't let go. Yes, it did. Yes, it did. It let go. I'm let go. So now I have. This is a bad circuit because I got two TM4C123s, but that's okay. We're gonna fix it. Okay? So on this circuit is my Lab 3, which has now both the booster pack and the single chip. In order to get things to click, you're probably going to have to change the grid setting. Depending upon how you built your Lab 3, how close together your pins are. I know with my Lab 3 and the starter file for Lab 6, I had to change the grid down to 25 mil with a quarter grid snap in order for me to be able to click on it. So if you find yourself you can't click on a wire with the mouse, decrease the size of the snap on the grid. Okay. So now from a 25 mil score relative to the SCH, I can click on things. All right, let me zoom in and see what I have to do here. Okay, you see the two PE4s? There's one over here and there's one over there, and I want to connect them. So I'm going to go to my trace here, and I'm going to click PE4, and I'm going to click there. You see how it made a dot? They are connected. PE3 to PE3, PE2 to PE2, PE1 to PE1, PE0 to PE0. Okay. Now if I'm completely successful, and I make sure I get all the port E's done before I do the next step, is I click on the selector, and if I click on the booster pack and I delete it, it should be pretty again. Okay, so I'm going to delete it, delete, and I got close. It's not pretty, you see that? I missed one. Whatever, undo. I don't know where it was connected, but it's not connected to the right place, so I'm going to remove this wire. delete, and try it again. Okay, so I missed one. I don't know why it went bad, but it went bad. I don't know where it was connected. All right, so now I'm going to try it again. Click. All right, delete the booster pack, and now I got everybody all connected. Now I can go around making things pretty. As a matter of fact, I love to have the net names on all my wires. As a matter of fact, I'll talk about nets in a moment. Oh, I got two 3.3 nets. That's cool. Display net name. Display net name. All right, so I got my display net name. Display net name. All right, so I got my my switches connected up to port E. Questions there? All right, let's do another easy one. Port D is fairly easy. Now, what I got to do is I got to find where port D is. There's two port Ds. There's one in my booster pack, and there's one in my chip. There's my chip one. Undo. Move it up here, close. Now, you can either align it next to it, or you can get close. Now, somebody tell me what they see different about these port Ds. See the difference? One has got 8 pins, and one only has 6 pins. On your booster pack, they don't let you add PD 4 and 5, but in Lab 6, you could have had PD. Okay, anyway, I'm going to connect them up just like I did the other one. I grab the wire 2. I go over here, and I'm going to tie PD7 to PD7. Okay, I'm going to tie PD0 to PD0. And you can spend your whole life making this pretty, but you got other classes. Okay, so I'm going to delete the booster pack, and again, once I delete this booster pack, it should look pretty again. Okay, let's try it. Delete. I lost PD7. See that? I lost it. So try it again. Okay, fine. Let's try delete that again. Okay, let's try. Oh, I don't know what went wrong. Okay, let's try. Already exists. Okay, fine. Let's try deleting it again. Now, sometimes, okay, there we go. PD7 is fine now. Again, you can make it as pretty as you want. I like to have my display net. Okay, so there I made a mistake. Okay, that's the wrong net name. So I'm going to make that PD0. Maybe change net to PD0. All right, now I got the hard one, which is PA. Well, it's not that hard, but it's got a bunch. So again, I'll bring it over here. Zoom in. Now, one way you can do it is get the pin, get the one halfway between before you connect it. So PA7, PA6, PA5, PA4, PA3. Okay, that's okay. No, PA2. One more. All right. There are no more port connections, so I'm going to delete the booster pack. Okay, I'm going to delete it. There we go. Beautiful. Okay. You need some debugging. You need some debugging feature. One of the debugging features you could do in both Lab 6, 7, 8, and 11 is use the logic analyzer. The logic analyzer, you know, is an 8, 16, 24, 32 channel device. And so I can take some unused pins down here and connect up the logic analyzer to pins on port B. Now, when you do lab 7, hook a bunch up. When you do lab 6, I'm not going to hook that many up because I'll just have to work harder on the next thing. Again, I like to have good names. You see, this is a net which has got a weird name. It happens to be PB1, so I'm going to call it PB1. Whoops, that was PB0. Oops, that was not right. Change that back. Now, sometimes you have to delete the net to get it to go perfect. PB0. Change this one to PB1. You can't pass either lab 6 or lab 7 with any net names that begin with an N, that have the numbers in it. You got to change them all to something that's fun and easy to understand. And so now I'll be able to plug my logic analyzer right onto the board. Well, it's lab 6, it'll just be a piece of paper. But when I get to lab 11, plug it right on the board, automatically hook up the logic analyzer to those pins, and I can debug with profiling. All right, let's go do the power. There's a couple of ways to do power. One of them's already, okay, now change my name. Nobody looks silly. Shall not look silly. No looking silly. Spell your name right. All right. Copy. Right here. Paste. All right. We're going to talk about regulators, but as you know, a regulator takes a battery voltage or some wall wart voltage and produces a stable output. What I have here is some battery voltage larger than 3.3 plus about 0.7. So as long as this is bigger than 4.2, this thing will come out with 3.3. This regulator will drive up to 100 milliamps. And so if you're, oh, there's my dropout voltage. So 3.3 plus 0.35 is what you need on this side in order for this to work. So in my alarm clock, that's plenty of current. 100 milliamps is plenty of current, so I'm going to leave it there. What I'm going to change is where I get my power from. And so you could hook in a micro SM micro USB connector, but I'm going to connect up a okay, not add text, I want a thing. Okay, so I'm going to take a 2-pin power connector, 2-pin power, header 2, that'll work. Okay, let's put a header 2 right there. Okay, escape, cancel. So I'm going to delete this USB power because that's hard to solder. Well, or it's beautiful, depending upon where your battery comes from. And I'm going to hook up that there, and I'll hook up this. Okay. So basically what I have now is the ability to put a connector down on my board to get power. Okay. These are you'll see them when I get to the PCB, but those are test points. I'll be able to hook an alligator clip or a logic analyzer, not a logic, oscilloscope probe to these. So I'm done with this phase. Any question? Oh yeah, down here is the crystal and the power regulators. In lab 6, we're just going to leave it there. In lab 7, we're going to take it out and hook up the launch pad back again because we don't have the. Okay, questions on this phase? I just basically made new power of my lab 6 using the chip instead of the launch pad. All right, so let's tools, schematic, forward design change. Forward design change is going to take all of the stuff that's in this SCH and transport it over. Before I do that, let's look at my nets. You do see I have a net error. Does anybody see it? Okay, front row people, can you see my, I have that net, which is plus 3V3. Then I have this net, which is plus 3.3. That's a mistake. Okay, so before I transmute it, let's go ahead and fix it. So if I double click it, I can see where that one is. And I double click that one, I can see where it is. And I'm just going to rename this one to match the other one. Right? So I'm just going to rename this guy here, change net to 3.3. And it's going to give me a warning because now I'm merging these two nets. Right? I don't want to have two 3.3 volts, so I'm happy there. Okay, so I got one 5 volt. Of course, it's probably a 4 point. Okay, it's a, you know, whatever. It's a. But all right, I got one. Ground is. Oh, there's one more. This will get me points taken off. I have a net which begins over there, and so I'm going to rename this net to something that is fun, obvious battery, maybe. Oops, I already got a battery. Let's call it raw battery. Something. Okay. So, all right, so I got. A fun thing to do is to click on all these nets to see if you've wired it up. A very common mistake when you get to lab 11 is you have two wires that sort of go close to each other on the SEH, but they're not actually the same net. And when you get to building the PCB, they won't work. They can't just be close. It has to be the same net. And so things that are kind of complicated, like I can look at PD0, which is my speaker, going to Q1 base, going to speaker minus, come on over here so you can see, speaker minus, going to speaker plus, which isn't speaker plus, it's 3.3, all right? Anyway, all right, so now I have to save, forward design changes, all right. Now it got really hard, okay? That was the easy part. This is all the crap I got to get on that PCB. Or this is the really fun part. Now what I want you to do is think three-dimensionally. You have your printed circuit board with the processor on it, and you have your display, and I'm going to put them on opposite sides. Okay, so I'm going to grab the. If you look at the silk screen of the processor, you're going to see it's red for copper and cyan for silk screen top. See that? Red, copper, cyan, silk screen. U1 silk screen. And when I grab the display and I want to put it physically on the other side of the PCB, I am going to flip it. Okay? Now you go, not much happened, but the color is very different now. The silk screen is now blue. That's the other side of the board, and if it had any wires, it's going to be, it's going to be blue as well. So. And then now I'm going to rotate it so that it fits on the board. Okay, so I don't know where to put it, but I'm going to put it, if you look, all right. This is going to be a drill hole for the riser for the board if I want it. These are going to be the drill holes for the PCB onto the box. And so there's the programmer. That's the JTAG programmer. Those 5 pins there. And now if you physically look at the color that it is, you can see this is cyan. So it is on the top of the board. whereas the LCD is on the back of the board. So even though they exist on the same plane, the LCD is on the back, which will be the top of my box, by the way, because my box is going to have a hole in it, matching my, but the processor and the debugger is going to be on the top of the board, which will be below the top to the board. Okay, so all right, so now I got to decide where to, you can sort of tell from my box where I want to put my switches. So I'm going to get not very elegant. I'm just going to grab them, put them approximately over here. So now I'm thinking physically, where do things go? And so I've got two really objectives here. One is to make it aesthetically pleasing. Okay, let's see. The green one is the size of my PCB, so that has to fit in the box. What do I do if I need more space? Well, I'll just make the PCB bigger. So I'll move this over here. Over there. I'll just make the PCB bigger. It gives me more room. Again, for Lab 6, it doesn't really matter how big your box is. You can have whatever box you want. But basically, I'm going to put my now these switches, it doesn't really matter which side of the board they're on because it's symmetric. Right? I could put them on either side. So I want to go around and now I'm going to think about where do I want my reset button. Do I want to push my reset button from the bottom of the box? Right? So if you look at my box here, the hole for the reset button is actually on the bottom of my box. And so I'm going to put the reset button on the top of this PCB, because the top of this PCB is the bottom of the box. All right, let's see what else is interesting here. Where in this box is my battery? I don't know. Somewhere, it don't matter. And so, wait, where am I going to put my logic analyzer? Sure, I can put my logic analyzer somewhere. The way the logic analyzer works is if you come straight in, now this is going to go, this logic analyzer is actually going to be poking down, which is okay. If you put a right angle on it, then you can have it poke out. But if you're going to put a right angle on it, these lines here have to be ground. Because you don't want the right angle to go in, you want the right angle to go out. But you can have it on the other side of the box. If you want it to come off the top of the box, I don't care. All right, unlock that one there. Okay, so basically now I got to get all the parts on there. And there's I first put on the pieces that physically matter. Where's my drill hole? Where's my display? Where are my connectors? So where's my power? That one there. Okay, so I'm going to put that's where my battery's going to come in. This is where my speaker is going to come out. I got a power LED, which I'm going to put right here. What else do I got on my box? That's enough. Okay. All right, so I'm going to physically place the things that matter, and now the trick is to get things on there. Okay, let's look at the yellow wires. The yellow wires on here are called rat's nest, and they represent things that have not yet been connected but need to be connected. And so if you want to rebuild your rat's nest, you can do a design rule check without the nets on it. So I'm going to do a design rule check without nets. See that? And then it will redraw all my wires. Given the fact that I moved it around. And so the trick here is to move stuff around to minimize the net. So for instance, you see that these two wires are crossed. I could flip the device. You can see that the resistor associated with this diode goes there. So if you see that, you see how R3 has got got two nets that cross. I'll just rotate it. So the fewer crosses I can place at this stage, the easier it will be. There's the pull-up resistor for the reset line. There's the power connector for. This is my regulator, my input cap, my output cap, my battery. All right, let's see. I got my ground. You got my ground. I got, what's this one? That's another ground. These are the pull-up resistors for the device, and so I want to get them close to their thing. And so as I bring it close, I can see that this resistor is associated with that switch. But you see it's reversed. You see that? So I'll flip it around to reduce the number of I think that's it. What's that? If you zoom over a rat's nest, it'll tell you which one it is. All right, which one is that? All right, 13. Let's get these up here. 12. All right, that one goes there. Rotate. 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 Get out of the way. Yeah. Rotate. Oops, I got in the wrong spot. I'll move that there. Okay, so again, I'm trying to place things on the board so that it physically fits in the box. There's the base resistor. You can see I made a mistake here. I've got a 1/4 watt resistor here. You see that? That's a 1/4 watt resistor. I don't have any 1/4 watt resistors, so I can fix that mistake. I'll go back to, let's do a save. I'll go back to the SCH and fix it. That's a 1/4 watt resistor. All right. I want a 10K 8th watt resistor, so I'm going to change it to an 8th watt. Now, unfortunately, sometimes it changes the value, and it happens to change it to 10K, so I'm okay, that's 10K. So forward save, forward design changes, and it changed that resistor out, so you see there's another resistor somewhere to go. There it is, right there. But now it's the right size. The base, again, I can flip this around so that it has fewer wires. There. Oops, what's that over there? I got one of these. What's that? That's my, what's that? Oh, I see. That's one. One of these is a switch, and one of them is the. All right, put this down here. There we go. All right. Rotate. 270. There we go. All right. Okay, let's see. This one, that'll be fine. All right. All right, I'm ready to change another phase. Questions on what? Again, I tried to minimize the length of the wires, the yellow wires, and you notice my these were the port B pins, which have to go down there. I could have put the logic analyzer up there. I could have, but you see, I got a pretty simple connection for the okay, what are these? That's the 3.3. These I got the 3.3 wires. Oh, that's okay. That's fine. All right. Questions? So now I'm going to route it. Let's start with power. Now you can either start with the hard things or the easy ones. I'm going to start with power. When I go to route it, that's a track. I am going to choose the style. Okay, right there. This one's the track style, not style. Okay. Zoom in. Yeah, add track. All right, that'll work. Let's do, if you click on something, it will, you can see down in the bottom, this is the raw battery, okay? And the raw battery is going to the switch. I'm going to change the style to be bigger than, I'm going to use a 20 mil trace on the power. Oops, that's the bottom. H. Okay, escape. Sorry, that again. All right. Style. Power minimum, then layer. I want it on the top. Now, okay, that was wrong. That's bad. Okay, where am I supposed to go? Okay, so let's click on it. All right, going over there. All right, fine. Escape. Let me reverse that other thing. Okay, escape, undo. All right, let's rotate this guy. Rotate. There we go. All right, I want the layer on the top. That's okay. I don't want to cancel. I want the size. That's an S to be power nominal. And then there we go. All right, so I made a trace. And so electrically what's happening is the power's coming into this. This is going to be an external on-off switch, and that is going to be +5. And so if I move these things over, I can put my test point right in there. And it'll be prettier. It's probably better to move stuff around before you start tracing. Okay, so again, I want the top. I want the, if you can read the thing on the bottom, it'll tell me it's a +5 net. On top, copper 20. That's what I want. So I'm just going to connect all of these 5 volts together. One of the things I can do is click on the net. So that was my +5. So I'm completely done with +5. That's the only place +5 goes on here. Let's do another hard one. Let's do ground. Ground goes a lot of places, and you go, hey, John, how do I get them all? Well, I go, well, what if I flip the reset switch? That may be easier. There's actually a simple rule, is I can use top to down and signals that go vertical in one color and signals that go horizontal in the other color. That's a good way to do it. So I see that if I flip this guy at around to 180, Again, I'll do a design rule check here to get the nets to come out. All right, that didn't actually make it better, did it? That made it worse. Ground. Oh, that's okay. All right, so now I'm going to tie all the grounds together. So I've got a strategy here. I'm going to go around the outside. That's my strategy here. I'm going to make a ring around the outside of this thing with ground. So, yeah, when I build my PCBs, I often will use a ground plane, but I don't want you to use a ground plane because it's really hard to make corrections, and I'm being a little bit ugly here. Fine. So I'm going to go over top of that one. So let me move it out of the way here. So I've decided to go around the outside with ground. Okay, now I'm going down. Now you can see I have no yellow lines that have to go underneath it. So I could stay red, or I could flip over to the other layer, L, and put it on the bottom. So I've decided to go vertical here. Okay, I'm being ugly here, sorry. My 31-year-old son is a I don't know, OCD or whatever. He spends hours on his printed circuit board. His rule is to minimize the number of vias. My rule is to make it work. And then hire somebody like him to do it. Now this line here is now what you call it, horizontal again, so I'll go up red. I'm going to go back to red, top. So layer, L, switched it to copper. Top copper. And now I'm going to tie all these together. Now, in general, you don't want to have a star, you don't want to have a circle. So I'm not going to go all the way around. These guys are the high current ones, by the way. That's the speaker, so I'm going to come this way. Layer. Again, I'm just going to follow my rule even though I didn't need to. That's a whatever vertical line, so I made it on the okay, layer, top copper. Okay, I gotta go. All right, so then I can click on the ground, and they're not all tied. I got some work to do here. Okay, fine. I got some work to do. I got to tie those to this. So I'll come. There's a ground right there. So I'll go red over here. What's yeah, the old layer. That's already red. Okay, so I'm going down now. So I'll go on the top, on the bottom. Again, you can see that the light blue is on the bottom copper. All right, I got some more. I got to get the processor isn't yet. Okay, I'm getting some more over there. So let's go up here, layer, bottom. Yeah, because I'm going up. Yeah, wrong one. It's Control Z. Escape. Control Z. Control Z. Okay, try it again. Layer bottom. Yeah, that's what I want because I'm going up. And now I'm going over top. I got to get there. And the tricky ones, by the way, are the processor grounds. Okay, so let me click on ground again. And you can see these are going to be easy right there. Because I can just go up and get that one. That's a ground right there, so I'll go up and get it. Okay, blue. No, I got to be on red. All right, let's see. I've got to get into that. Now, if you get into these, you notice how these two are. Now, this is the tricky thing. If you're going in the processor, because of the pitch, you have to start in the processor. You can't end in the processor, it'll make a mess. So when I want to hook up this pin, I'm going to start here. Now, unfortunately, let me show you what these pitches here, properties. These wires in here are 8 mil pitches. In order for me to get to that pin, I need a tiny pitch. So when I get to it, if you notice what happens if I click on it, oh, that's fine, that's perfect. Okay, so that is ground 8. It's a ground top copper 8 mil. And so I'm going to come up here and stop. I'm going to come up here and stop. I'm going to come over here and stop. And now I'm going to come in with a big wire to those 3 pins. And that'll get all my ground. You see, I can come right down here, right from here to there. So I'm going to take a big wire now and come right into that spot right there. So again, if I look at my ground, oops, I got some more over here. I got to get those. Okay, there's a ground. I can get that one. Okay, quick. I got some more to do. Ground. Okay, so this is a down, so I'm going to make it on the bottom. This is a down, so I'll make it on the bottom. This is a down, so I'll make it on the bottom, bottom. Okay, so let's try it again. All right, I think I got them all now. All right, so let's do 3.3. Questions on ground? Now, in my medical devices, I will lay a ground plane for electromagnetic noise interference. Don't put down a ground plane unless you're sure you made no mistakes, because it is real easy to correct mistakes if you don't have a copper pour. Now, my really expensive medical devices, we have 4 layers. I'll have 1 layer ground, 1 layer 3.3, and the other 2 layers will be signals. Again, for a low power, a low noise system. So there's my 3.3. I'm going to use the same strategy I used before. Is I'm going to use a fairly large trace on this 3.3. That's a 20 mil trace. That's the wrong color. Escape. Try it again. Layer top. Okay. Again, if there's not a yellow wire going underneath, you saw that it would give me an error. What's going to happen here? That's a bad thing. You see what I just did? I just crossed it. So I'm going to put in I could either move that other one to blue, which would be the right thing to do. So let's do it that way. Escape. So if I go to my selector, click on this and change its layer, change the layer to bottom, it automatically added a via here and made it blue. All right. That would be the right thing to do. Again, my son would be really mad at me for having vias. All right, so I want to get, I'm going down. Oops, that's not good. That's not good, see? I just got the cross with the other color. Sorry. I can't cancel. Cancel. All right. Layer, top copper, there we go. All right, that's a down, so I'm going to make it on the bottom. All right, so again, you can see that this is the 3.3 volt path that's going into the processor. All right, so I got to get all these other 3.3s connected. Let's see, where's my 3.3? Yeah, that's it, that one there. So I'm going to come around and get this one. That's 3.3. Is that the right one? Layer top, okay. And then this one I'm going to go on the bottom. That was bad. All right. LDO, here's something you know. Give me the 2 ways to reduce power in your system. You've got an embedded system on a reduced power. 2 ways. Slow the clock down, get on the PLL, run at a megahertz, run at 500 kilohertz. What's the other way? And what's the relationship between power and bus speed? If I, yeah, they want the equation. If I double the bus speed, how much power do I take? If I double the bus speed, how much more power does it? The voltage is constant. Power is voltage times current. So if I double the bus speed, how much more current do I have? The answer is double. I'll prove it to you someday if you want. What's the other thing I can do to save power? I can't do it in 445L, but I can do it in life. I can reduce current. What's the other term in power? Voltage. So I can, it turns out your processor is actually running at 2.5 volts, not 3.3. And that's on this circuit, that's what LDO is. That is the 2.5 volt power supply running the architecture. It just depends that run at 3.3. The architecture runs at 2. But don't tie 3 volts to 2.5 volts. That's fire. That's bad. Okay. All right, there's another one. 3.3, I can get it. Wow, it's already connected actually. All right, so if I look at my 3.3, I got to get that one. Let's see, what else do I got to do? I got to do some more. Okay, so I need 3.3 over here somewhere, right there. So let's go get it. All right, so I'm going to go red here. Red. And now I'm going to go down. So you note if I change the layer while it's moving, it adds a V. Okay, let's see what else. 3.3. Yeah, that one's connected. I bet you the speaker's not connected. Okay, let's see. Where's my speaker? That one. Yeah, there's one. Oh, and a display. So I'm going to go get a 3.3. Let's see, that's 3.3. I'm kind of close. Yeah, I'll go get it from there. All right, so here we go. Grab a 3.3 from here. It's. I hope it's red. No, yeah, it's already red, so that's good. And then I'm going to go down with blue and hit right there. And then I'm going to go down and hit right there. All right, so let me do some easy ones. This one is fairly easy. That's the base current. How much current flows through this is going to be on the test, by the way. How much current is flowing into the base of this transistor? A lot or a little? The base. A lot or a little? Well, I don't hear your answer. A lot or a little? A little. So I'm going to use a small trace. How about the collector? A lot. So I'll use a big trace. All right? So it didn't choose me a big trace, so I'm going to change it by hitting S and going, hey, make it big. All right? So 15, 20, how about 20? All right, I'll make it 20. All right. So if you look at the speaker current, by the way, you will see that the plus 3.3 is a 20 mil trace right off of the regulator down to the speaker, across the speaker, back the transistor, back to ground. See, the speaker current is in this loop. Doesn't go into my processor, doesn't go into my delicate stuff. All right. Okay, so this is the crystal. It, as you can see, laid out for you already. Unfortunately, your Lab 7 won't have a crystal on it. Well, you're going to use the launch pad, but anyway, nevertheless. Okay, so now I can do some. The LDOs are already connected. The oscillator is connected, and now we're just going to go pin by pin, try to get them hooked up. Let me do the. I don't know. They're all hard at this point. They're all hard at this point. You got to get them there. I'm going to use little traces because there's no more large currents here. So there's PA2, and so I'm going to click on it. Okay, where's my PA2? Okay, see, look at how ugly that is. That's going to connect things together. So I got to change the size of it. Okay, not the layer, the size, and I need a signal minimum. I need that to be an 8 mil trace. I can see where I'm going. That's that one. Boy, I don't know. I'm just trying to get out of the way here. I don't know. Boy, sheesh. Sometimes you're lucky and it's easy. The first one's always easy. I just got to get a whole bunch of those traces to fit. That's big again. I'm going to change the size down to minimal. Yeah, I don't know. Sheesh, where am I going with that one? Fine. Crap, it didn't even tell me where I'm going. That's PA3. Yeah, the PA3 is that one there. Yeah, come back. Save often. Escape. Save often. Let's try that again. I'm clicking this one. PA3. How about I clicked it over here. That's what I want to do. I'm going to connect PA3. You see that? Yeah, let's try that again. Yeah, that's what the back button is for. I actually brought my good mouse. All right, you just got to get out of the way here. I'm on the wrong pin. Thank you. What's wrong with me? That was ugly anyway. Okay, size to nominal. Okay, so I'm going to go close, but not too close. Okay, so now I got to get. So here I might want to change it to blue. Layer, come up here, change it back to red. Of course, my son would hate that. All right, let's do PA4. There we go. Now I'm cooking. I got to get down there. Oh no! All right, so but you remember a cheat code here, right? Watch. I can change the layer of that. Watch what happens. Layer. Let's make it bottom. Boom. Now I got a hole. I can get down. I can go between those two now to get into the promised land, so to speak. And I'll move it a little bit further out of the way here. Okay, so how about if I get out there? All right. Now that's too close. It's going to make a mess. All right, there we go. All right. All right, so PA5. All right, let's see if I can finish this before class is over. Layer, no, size, nominal. Where am I going? Right there. That's not too bad. Not too bad, not too bad. I don't know. We'll see. We'll worry about the mess when I get there. PA6. Got to get up there. Yeah. I could change that to red and go between them. No, I got to get PA7. That's all right. I'm good. Watch. I'll violate my rule here. I'll put that on the other side. Right? That's on the other side. Put this one on the other side. And now I can go between them. This is a fun part. This is a fun part. Not too horrible. All right, that's still not the right size. I want signal, nominal, no, minimal. There we go. See, now I'm going to change onto the bottom. And now I can go between these. All right, let's try PA7. Size, nominal. All right, now I backed myself in a corner. You see that? I am completely stuck. But what I need to do is I need room for a via. I need room for a via. So watch what I'm going to do. I'm going to quit that. I'm going to move this thing down by first killing that. That's in my way. All right, I'm going to move this guy down so he's out of the way. And now I'm going to reconnect this one back here. Because you can't put vias are copper. You can't put copper on top of copper. It's unhappy. So I'm just going to do it like that. All right, now I got a spot for a via. Size. Now I can come into this little hole right there. Change to that. And okay, now I'm stuck again. Yeah, well, whatever. Okay, I'm good. Watch. Stop that. There's hundreds of ways to make this happen. This guy's my trouble. So this guy and that guy. Control Shift. Control Shift. No, Control. All right, change. Okay, let me move it over here. Layer. All right, so now I can get around it now. Keep going. I go back over here, finish this guy off. Yeah. All right. How am I doing? Time. All right. What pin is that? That's PD7. PD7. All right, that's not too bad. I can get there. Don't be a hater. I can get there. I got to get across that one. So come over here to a via. Go layer. I'm blue, so I can go all the way across here. So I'm still blue. I go up like this, and I'm in. There we go. All right, PD7. What pin is this? What pin is it? Okay. Let's see. No. Oh yeah, that's a 3.3 volt. That's the what you call it? That's the backlight. All right, good. I will do another design rule check and see what nets are left. So there's a lot fewer yellows. I got the display hooked up. It's not pretty. I got a mistake. You see that? That's a V. You can sort of see that those two yellow circles on top of each other. That's not good. So I will move this guy down. There we go. How about that? All right. If I do another design rule check, it should go away. There we go. No errors. Let me start doing a. Yeah, those are fairly easy. Those are easy. These are. If you want to volunteer to do something, do the PC ones. These are fairly easy because I've lined them up. Not much current. They're lined up here easy. Oh, you can see the mistake I made. I double clicked it. See that big black thing? That's bad. Click it just once. Yes. That would have been a hard one to find because it would have been under the pad. All right. I'm almost there. Got to do the switches and the two pins. Let me pretend I'm done and do the next design rule check, and that is to click nets. This is going to be the final, we're all happy it can be built. And if you look at your design rule check now, you can see that I somehow not connected some 3.3s. I don't know. We'll see where that. I've not connected PE1, reset, and wake. So it's PB. Yeah, PB. Those are my mistakes. Gap and net means those are nets I haven't done. So I've obviously missed some 3.3 somewhere. Oh yeah, I haven't cooked up 3.3 to the switches yet. The next phase will be to make it pretty by pulling down silkscreen. So I'm going to put my name on here. Oops. Click. I'm going to put my name here. And I'm going to be very happy it's mine. I'm going to put my name here on the top. I'm going to put my name on the bottom. Because you remember what purple is? Purple is the silkscreen on the bottom. I'm going to put down the date. 445L, the date, my name. So that's the silkscreen on the bottom, which will be actually the silkscreen on the top. That's the power connector there. That's the ST7735. There's another power switch on the other side. There's a ground. Let's see what else I can put on there. The logic analyzer, yeah, that's what this is. Just so your lab partner knows what it is. You want to violate the copyrights of the football team? Either you do or you don't. Up to you. They will get you. I got tenure. You don't. So yeah, that's the battery. So what I'm doing is I'm putting silkscreen down to help me figure out what it is. All right, so the next, I'm not totally done, but I'm pretty close. The next phase, yeah, you can make it as pretty as you want. Again, save it. I'm going to do 2 prints. Okay? I am going to first just print what you're going to see on the top. Okay, so I'm going to do a print, and I want to see the top silk. Come on, don't crash. I did just save it, so I'm probably fine. Top silk. You should save more often than I save. All right, cancel. Let's try that again. Print. Top silk. There we go. Now you can have the top solder mask if you want in the top documentation. I guess you can't. Okay. All right. It is very important that you print 100%. Because you're going to print that piece of paper out and your thing has to fit in your box. Okay? So I'm going to print it not fit. I'm going to print it 100%. Okay? I am not going to rotate or mirror or whatever. I'm going to print the top copper, the board outline. Okay? And then my printer happens to be a PDF, so that's fine. I'll eventually have to print it to an actual printed circuit board. So that's what it looks like on the top, which is actually the bottom of my board, because when it goes in the box, the thing that's the top copper is actually going to be on the bottom of my box, because I don't know, it was easier to flip the display than it was to flip the microcontroller. You're going to look for weird things, like you notice I've got some of these silk screens upside down. You know, lab partners don't like that. Your TAs don't like that. It's upside down. So I got to flip them over before I finish. Okay, I'm going to print that out, and then I'm going to print it again. This time I'm going to print the bottom silk. Come on. Cancel. Try that again. Print. I guess it's a mouse thing. Bottom silk, there we go. Bottom copper, there we go. No top copper. There, okay, it's just a mouse thing. Bottom silk, bottom copper. If you want the bottom documentation, that's fine. It actually doesn't show up anywhere. Again, I want to 100%, but now when I do the bottom, I'm going to mirror it. Okay? I'm going to mirror it. You'll see what it looks like. It's going to look beautiful. I got to give it another name. It's the bottom because I want both. Okay? It's going to look beautiful because the silk screen has been mirrored. So everything that you see that's a bottom silk is going to be beautiful. But when I go to print this, I'm going to print it on the bottom of the piece of paper, the bottom of the cardboard. I'm going to print the other one on the top. A lot of stuff shows up on both, like all the through holes are going to be holes on both sides. So I'll print this on the bottom of my piece of paper. I'll print the other one on the top. All right, questions? I got close. Yeah, I got close. I got a couple of traces left, and then I'm done with Lab 6. All right, well, thanks for coming. Good luck on the test. Go ahead and make sure you go to the right room. It is not this room. It is not this room. All right, stop.